Now we're going to start our second lesson called Powers and Exponents. And just as we did in our first video lesson, we are going to go over the vocabulary words first. This time there are three. Let's take a look at the first one, a power. Now the power is the result of a repeated multiplication of the same factor. Our second one is base. That's called the definition of base is the factor. And our third word for this lesson is exponent. And the exponent is the part of the power that shows the number of times that the base is used as a factor. So in other words, there are two parts to a power. And I know that you have at least seen powers before in your work, where you had a larger number and a little number hanging in the area where an apostrophe would hang in a word. That bigger number is the base, and the exponent is the small number. And when you see a power, what you're really looking at is a multiplication expression. And just to rephrase what these definitions are saying, in this power, in this multiplication expression, you're going to take your base, which is the bigger number, and you are going to multiply it over and over and over again. And the exponent, that little number that's hanging, tells you how many times your base is going to be multiplied, in other words, used as a factor. And this might be a little confusing, but remember what I said in the last video. As we work through, this time are 4 examples, and as I use these words and you use them too, you will come to have a really good understanding of them. Here's our first example. Listen to the directions. Write the factor using an exponent. Well, as I said, powers are multiplication expressions. Here we have 8 times 8 times 8 times 8. In class, I will refer to this as the expanded form. And it's the expanded form of the power that we're going to write right now. As I said before, the number that gets multiplied repeatedly is the base. That's the bigger number. And our exponent, our little hanging number, tells us how many times, in this case the number 8, appears in this expression, and it is 4 times. So there are 2 different ways that you can read this power. You can either say that this is 8 to the 4th power, or 8 to the power of 4. Both are acceptable. Now, just in the second example, I'm purposely using a variable just to show you that we are going to model what we did up here with numbers. It is exactly the same for when we're using variables. Here, our base is going to be the letter Y. So I'll make that on the bigger side. And remember, our exponent will tell us how many Y's there are in our expression. And in this case, there are 7. And again, the 2 ways that you can read that are y to the 7th power or y to the power of 7. Here's our second example. Here what we have to do is evaluate each of these powers. And what we have are 3 different values for the variable n. So I've set it up to start 3 times. Now remember what I said in the first video. This is not just about learning the algebra, it's also about working toward and having really good work habits. So when you write this onto your note-taking sheet and as you work out problems, both in your homework and in your classwork and on your quizzes and tests, these are the steps that I want you to follow. N to the 3rd power means n times n times n. Now firstly, we're going to work over here with n equaling 5, which means now that we've written the expanded form of this expression, we're going to substitute in the number 5 because that's the value we're working toward. So n to the 3rd power, when n is 5 times 5 times 5. And now you have to solve it. 5 times 5 is 25. 25 times 5 is 125. Now let's move on to the next one. Here we're told that n has a value of 4/10, in other words, 0.4. So again, we're going to do what we did here. First, we'll write the expanded form of our power, n times n for n to the third power. Next, we substitute in our 0.4. And then we solve it. 0.4 times 0.4 is 0.16, and you might want to do that in stages. And then 0.16 times 0.4, to bring this down, is 0.064. Now here, the actual computation isn't the difficult part. If someone's going to make a mistake here, it will invariably be with the decimal point. You have to remember that even though 16 times 4 is 64, because we have 1, 2, 3 places after the decimal, we need to have 1, 2, 3 places following the decimal in the product. And then finally we have a fraction, 1/2. N to the third power means n times n times n. Now we'll substitute 1/2 times 1/2 times 1/2. When you multiply fractions, there is no need, well, the denominator is the same here. But when you are multiplying fractions, you first multiply your numerators. 1 times 1 times 1 is 1. And then multiply your denominators. 2 times 2 times 2 is 8. Final answer, 1/8. Now example 3. We will be working out a lot of word problems, really in every single lesson throughout all of pre-algebra and algebra. And I know that word problems are intimidating to a lot of students. The fact that there is a lot of reading required is daunting. And a lot of times students will look at a problem and just think they can't do it just because they might not be able to understand what's being asked. Here's what I want you to keep reminding yourself. Think about the skill that we have been working on so far throughout this whole lesson. In this case, it's powers, bases, and exponents. And this is going to be true for every lesson you encounter through pre-algebra and algebra, and even beyond. When you're faced with a word problem, almost always it comes at the end of the lesson or somewhere in the middle, but it comes after you've already learned the base work for it, the actual computation or the new skill. All you're doing in the word problem is taking what you've learned and applying it to a real-life situation. So just remember, we're working with powers. Find the area of a square whose side length is 11 inches. Well, this is one of those times where you are going to be doing extra writing to help you work toward having really good work habits. And one of the things that's important for you to know are some formulas. Here, the area formula is something we will encounter very often in pre-algebra and even algebra. So you're always going to start with the formula. Area equals length times width. But for this lesson, I'm going to change it because we're working with a square. And what do we know about squares? Squares have 4 sides, and each of the sides is the same exact length. So our formula for area of a square is the side squared. And what does that mean? Here, what it means is side times side. And now we substitute. The area of this square will be 11 inches times 11 inches. The area of this square is 121 inches squared. Now what do you notice? We started with an exponent, we end with power, we end with an exponent as well. Because when you're finding the area of a figure, we're talking about a second dimension, 2 dimensions to the object, we're measuring 2 dimensions of it. And so that means that the unit has to also be squared because it's inches times inches. Notice I use my unit every time. You have to as well. And so now what we're going to do is one more example which uses a power, and this time we're going to use powers to find the volume of a cube. And now this will only work with a cube, just as in example 3, that formula will only work with a square because squares have equal sides, cubes do as well. And what are we going to start with? The formula. The formula for volume is side to the 3rd power, side cubed, because a cube, being a 3-dimensional object, has 3 dimensions that we need to measure. Height, width, and length. Length, width, and height. So we're going to start like we always do. Write out the expanded form of our formula, of our power, I mean. So s cubed, or s to the 3rd power, is s times s times s. And if we look over here, each side is 9/10 of a meter long. So our volume equals 0.9 times 0.9 times 0.9. And when you do your multiplication, you'll get a final answer. 0.9 meters times 0.9 meters times 0.9 meters. I apologize. And you'll get a final answer of 0.729 meters cubed. And the way to remember this is, however many times your unit appears in your multiplication expression shows the exponent that has to be in your